Hey everyone, welcome to Duality Repair. This time I'll be looking at a Yamaha P5000S power amplifier. Let's go ahead and take a look at the symptom. It's plugged in, pushing the power switch, absolutely nothing. No relays click, power LED doesn't come on, nothing. You can leave it on for as long as I want, it doesn't change at all. So go ahead and take the cover off. While I do that, I will show you the spec sheet if you're interested. Here's the first look inside the amplifier. I took a look around already and inspected for signs of blown, bulging, or leaking capacitors, as well as signs of thermal stress or damage. I didn't find any of that, so that's a good start. As far as the layout, it's a pretty recognizable layout. Again, it's a 2-channel amplifier, so our channel A is controlled by the board here on the left, channel B is controlled by the board on the right, and our power supply section is this entire center board. So since we're unable to power the unit on, I'm going to be focusing on the power supply section first. So let's take a look at the power supply schematic. Power comes in on the top left here. It's going to go through the normal filter, capacitors, and inductors as well before it comes into our first transformer, T401. This is our standby transformer, and it's going to supply voltage to our IC up here, IC403. IC403 is a 15 volt regulator, so that's going to supply 15 volts down here to this bottom section. The bottom section is the driver section for the main transformer T402. So our 15 volts is going to be supplied into the regulating pulse width modulator. This is just going to create a high frequency pulse width modulation, and this is going to drive the high and low side driver. The high and low side driver is going to take that high frequency pulse width modulation from our IC on the left, and it's going to drive our two transistors up here, Q406 and Q407. These two transistors are going to drive our main transformer T402. T402 is going to supply the rest of our voltages for our unit, so plus 15, minus 15, as well as plus 24. So the first thing I want to do to try and isolate this problem is I'm going to start by looking at the standby circuit. So I want to start by looking at the pins on IC403, which is our standby regulator. If we don't have 15 volts coming out of there, the unit's not going to turn on. So let me start there. So IC403 is right here. And I can't tell which pin is which, so I'm just going to look at all three of them. One of them should give us 15 volts out. I'm going to power the unit on. I'll start with the first pin closest to us. So that says negative 3 millivolts, obviously not what we want. Let's check the second pin. Second pin again is about 3 millivolts, nothing. And I'll have to kind of angle a little bit differently to get the third pin. Also nothing at about 1 millivolt, so absolutely nothing coming in or out of that IC. So that eliminates a lot of our power supply section. There could of course be other issues, but I'll start by working my way backwards from that IC. Alright, time to start isolating our power problem. So again, we know we don't have any output from our 15 volt regulator IC403, so I'm going to start by working backwards. I'll start at the switch. So we should have our mains voltage, or 120 volts AC, at our switch at connector VI, which is the purple. It's labeled pink, but it's purple in our case. And I don't even need to have the switch on for that. So let's take a look and see if I have power there, or voltage there. And no, I don't. I have 0.663 volts AC. That's not it. So we don't even have AC volts getting to the switch. So let's go backwards and see which of these components is bringing this down. So we can see our first component back is C425. So let's go ahead and take a look at that pin, 425. And you can see we have the same, about 6.67 volts AC, so no good there. So let's keep going backwards. Let's take a look at the input of these two resistors here. So R416 and R451. These are these cement type resistors right here, and the leads are hidden, so I can't check those directly, but I can check a lead of a component before that. So we see we have these series resistors R410 and R411 before that. So let's go ahead and take a look at R410. So here's R410. Hey, there we go. We have voltage, 120 volts AC, exactly what we should have. So we just completely isolated at least one of the problems. We have 120 volts AC before R416 and R451, and we have no voltage after those two resistors. So one or both of those resistors either went open or there's a connection issue. The only way to tell is to remove this board, which I'll do now. We'll take a look at the bottom and check to see if they're open or if it's a connection issue. Alright, here are those two resistors, R416 and R451. There's nothing obviously wrong with them physically. But I did check their resistance, and they're definitely open. So let's go ahead and take a look. They're supposed to both be 6.8 ohms. Doesn't need the meter in there. So here's one resistor right here. See, that's reading open. There's a second resistor here, also open. So I'll get these on order. We'll get these replaced. Since I'm doing an order, I don't really like to order one thing at a time. It doesn't really seem worth it with shipping. So I also inspected some other components. So there's the drive transistors, which are actually right here, and I checked those for shorts. No problems there, so I'm not going to need to replace those. I also checked the ESR of these main filter caps. They're perfect. They're well within spec, as well as these caps here, and then most of the other electrolytics I checked as well. You can see all a bunch of electrolytics. Again, no signs of bulging or leaking electrolyte, and with a ESR in spec, I probably don't need to replace them. I'll do another really thorough inspection of the board, as well as take an overview of the amplification boards, just to make sure there's no other components I want to order. But I'll for sure get these two resistors on order. I'll order a few spares in case for some reason there's something shorted and they blow right away. They go open right away. But I will be back once I get the new resistors in. The new resistors have arrived. Let's take a look at the old resistors. Pretty obvious that these had a problem. They obviously saw some excessive heat or current. I couldn't see this when they were installed because the burn marks were facing each other. So this is how I saw it. You don't really notice that there's a problem until you remove them and pull them apart. So I'll get the new ones installed. I'll get the board back in the unit and we'll be ready to test. I've installed the resistors in the power supply board, and the board is now reinstalled in the unit. I have already powered it up to test it, and we do have power now, but we have another issue. So I'm going to turn it on, but I'm only going to leave it on for a few seconds because there's definitely something wrong going on here and I don't want to cause further damage. So here we go, I'll turn it on. You can see we now have the power and protection LEDs. The clip and signal LEDs are on and they're blinking. I'm going to turn it off. And we also had the fan spinning, which is great. They were really quiet. So our power supply is now working. But if I touch these resistors that I installed, and I know you can't really see, I can feel the heat coming off of them without even touching them. They are screaming hot, and that's exactly what happened to the old ones. Something died on one of these two amplification channels, probably shorted, caused excessive current to go through the power supply board, including those resistors, and eventually they just burned up and went open, and then caused the power supply to fail. So in order to try and identify the problem, I'm going to disconnect the power going to each amplification channel and then power this up. And I'm guessing that we're only going to see the power LED. We're not going to see these clip and signal LEDs blinking. So let me go ahead and unplug it and then unplug the power. It's just 3 cables here for the left channel and 3 cables here for the right channel. Easy enough to remove those, so I'll plug it back in and turn it back on. Perfect. Alright, so now we just have the power LED. The protection LED obviously was extinguished, so that's good. I don't hear or smell anything. These are still hot, but if I turn these on when they were cold, I bet they'd stay cool. and they don't seem to be getting any hotter. Again, I'm feeling for the two resistors that I exchanged. Sorry, you can't really see it past these wires. If I move these, you can see them there, the white. Okay, I think I could leave it like this all day. It's just one or both of these channels has a problem. So now I'll plug in this right channel here. It's actually channel B. I'll plug that in, and we'll see if we're getting our same symptom. And if not, then we know it's our left channel, and vice versa. So power it off, unplug it, plug them in. All right, I've installed the power wires for channel B only. Channel A's power wires are still open. So let's power it on. All right, so the protection LED was extinguished. Our clip and signal LEDs are no longer on and blinking. So I think it's safe to assume that our right channel may not be functioning perfectly, but it's not shorted. The left channel is going to be our short. So I will definitely want to remove this entire board here, and we'll inspect all the transistors and diodes for shorts, and we'll do that in a minute. Before I do that, I want to make sure that channel B is working properly. So it's not shorted, but is it passing a signal, and is it passing it cleanly? So next I will hook the right channel up, or channel B only, to a dummy resistor. I'll insert its signal, and then we'll see what it looks like on the scope. If it looks good there, I'll plug it into a speaker and see how it sounds. That way we can just eliminate me having to even remove this board, and I'll just focus on channel A's board. So I'll get that all hooked up and I'll be right back. Here we are at the scope. You can see we have two traces. The sine wave is the input to channel B, and the flat line is the output. I will power up the unit, and then I'll turn up the volume and see what we get. Alright, so the unit's on, protection LED extinguished. I'm going to turn up the volume now. Cool. So you can see it's matched. And that's just a few clicks on the volume knobs. Let me keep going. Alright, I got a lot more to go on there, but I'm going to leave it there so we can see it on the screen. And the wave looks really good, so I don't think we'll have any problem with distortion. So I'm going to go ahead and hook it up to a speaker and see what it sounds like. Still have channel A of my scope hooked up to the input. I have the output now hooked up to a speaker. Let's see what it sounds like. Sounds good. So I think channel B is just fine. I just need to fix channel A. So I'll take that out and we'll inspect it next. Here's channel B's amplifier board removed from the unit. And I inspected all of the transistors. You can see we have one row here along this part of the heatsink. And this is for the positive channel. And another set over here for the negative channel. The positive tested just fine, but many on the negative channel were shorted. So all 5 of these were shorted. This one over here was questionable. I'm going to remove it from the board later and test it, and then this one was questionable as well. So I'm definitely going to replace all 5 of these. I'll probably end up replacing these unless when I remove it they test fine. What I'm also going to do, even if they test good, I haven't tested them yet, but I will test them, I'm going to replace all 5 of these resistors, as well as all 5 sets of these resistors as well. They're all within the current path, as we'll see on the schematic. And even if they test good or marginal, it's best just to replace them since they might be on their way out. So I'll also check the ESR of all these capacitors, the electrolytics. They all look fine physically. They're not bulging, don't show any signs of leakage. But if they show high ESR, even marginal ESR, better just to replace them now. So I'll take this off of the heatsink and I'll test all those components I just mentioned. If anything changes, I'll come back. And if not, I'll just come back when I have all of the new parts, the resistors, transistors, and possibly capacitors back in, and we'll get them installed and tested. Alright, I've removed all of the failed transistors from the board. I'm ready to install the new transistors. There's just a few things I need to keep in mind. Number 1, as you can see, I cleaned all of the old thermal compound off of both sides of the heatsink, so I need to reapply a liberal amount of new thermal compound. Number 2, after I do that, I need to make sure I install these insulators, and so that they're perfectly covering the body of each transistor. I need to do that because the body of each transistor is tied to the center pin, and the center pin is the collector. So if I were to mount each transistor, or any transistor, onto the heatsink without an insulator, I would just be shorting the collector straight to the heatsink, which would be no good. So I'll get all that done, everything will be installed, I'll put the board back in the unit, and we'll be ready to test. Hopefully we don't have any more problems. Alright, it's all done, all the transistors are back installed. Went a little overboard with the thermal compound, but better more than too little, so this will work just fine. And I verified we have no shorts between the collector of any of the transistors and the heatsink. I mentioned earlier as well potentially replacing these resistors and the resistors in between, but I checked all of them and they checked absolutely perfect, so there was no need to replace them. I also checked all of the capacitors, electrolytics. Those tested perfectly as well, so I didn't replace anything but the 7 transistors on the side. So I'm going to get this board installed in the unit and we're ready to test. Alright, time to see if my work paid off. I have channel B's module installed back into the unit. I'm ready to power it on now. Looks good. Protection LED extinguished, power LED is still illuminated, and we no longer have the blinking clip-in signal lights. So I'd say we resolved our short. Let me go ahead and feel the transistors, or the resistors, excuse me. Yeah, they're room temperature. So we fixed the short. Now it's time to inject a signal and see what we get on our output. Okay, we're back at the scope. I have a 500 Hz sine wave as my input. The top trace is channel A's output, which we know works. I'm going to go ahead and try and turn up the volume for channel B and see what that looks like. Looks good. Nice looking sine wave, no distortion, so I think this thing is fully fixed. I'm going to go ahead and clean up the cover and the rest of the unit before I put it all back together, and then after I do that, we'll come back and we'll hook it up to some speakers and see what it sounds like. Alright, there's another one fixed. It sounds really good. I'm going to burn it in for a bit and let it play maybe for 30 minutes and make sure it still sounds good after that, but I'm going to call this one fixed. Thanks for watching. We'll see you on the next one.